Atoms always like to be stable, and sometimes in order to attain stability, they tend to lose their electrons, especially the outermost electrons, to form cations. Cations are basically positively charged ions that are formed when an atom loses one or more electrons. So how does that happen? That is what we'll be discussing in this lesson. So now that we know what cations are, let's look at how some selected atoms form cations. So we have sodium on the screen. Sodium atom has an atomic number of 11, which is written as a subscript there. So sodium has an atomic number of 11. So if the atomic number of sodium is 11, what it basically means is that the number of protons sodium should have is 11, because the number of protons tells us the atomic number of the element. But this sodium atom is neutral. This sodium atom is neutral. All that means is that this sodium has proton to be positive 11 plus 11. So if it is a neutral atom, then the number of electrons are also 11. So it means the net charge of this neutral atom is 0, because positive 11 plus 11 minus negative 11, that is positive 11 plus negative 11, gives us a net charge of 0. So this is a neutral atom. But remember we said cations are formed when atoms lose electrons? Well, before we get to understand that, let's look at the electronic configuration of sodium. Sodium's electronic configuration is 281. 2 plus 8 is 10. 10 plus 1 is 11. If you haven't watched the lesson on how to write electronic configuration, we've already recorded a lesson on that. So do well to watch it so that it will make it easy for you to understand this portion of the lesson. So the electronic configuration of sodium is 281. If you pay very close attention to that, that means the last energy level of sodium has only 1 electron. Meanwhile, in reality, for it to be stable, it must have 8 electrons in its outermost shell to be stable. But here is the case, it has only 1, meaning it is lacking 7 electrons. It needs 7 more electrons to attain stability, which is kind of like difficult to get. So sodium will prefer to lose its 1 electron, its 1 outermost electron, that is the valence electron. It will prefer to lose it so that 1 energy level will be lost. So I take it back. You would see that there are 3 energy levels, so it will tend to lose this electron so that there will be only 2 energy levels left. What that means is this: we have sodium having electronic configuration of 281. The 1 electron will be lost. So as it is lost, the electronic configuration is now 2,8. So what does that mean? Well, the proton of sodium has really not changed. What has changed is the electron. So sodium still has proton of positive 11. Meanwhile, it has lost 1 electron, meaning the electron count has reduced from 11 to 10. So electron counts are now what? Only 10. So plus 11 minus 10 gives us a net charge of positive 1. So what that means is when sodium loses its outermost electron, 1 electron, it forms a cation, that is Na+. So this is how cation of sodium is formed. And if we want to write it in form of an equation, it becomes sodium, the neutral sodium, going into sodium ion plus the lost electron. For our next example, we'll be considering magnesium, the next in line after sodium. Magnesium has an atomic number of 12, meaning it has 12 protons. And since this magnesium atom is neutral, the number of electrons are also 12. So plus 12 minus 12 gives us a net charge of 0. So neutral magnesium atom is 0 in terms of charge. But here's the interesting thing. The electron configuration of magnesium is 2-8-2. 2 for the first shell, 8 for the second shell, and 2 again for the third shell, as you can see in the diagram. But interestingly, magnesium has only 2 electrons in its outermost shell. For it to be stable, it needs to have 8 in its outermost shell. So it needs 6 more in addition to the 2 to attain stability, which is too much to get. So it will be safer for magnesium to lose its outermost 2 electrons in order to attain stability. This is what happens. Those 2 electrons are lost. So now the electron configuration of this sodium ion becomes 2-8. This is much more stable than when the 2 outermost or valence electrons were present. So now what happens? Magnesium atom still has an atomic number of 12 or proton being 12. Meanwhile, the electrons have now reduced from 12 to what? To 10. So we have a net positive charge of 2. So basically, that is what has happened. So magnesium ends up forming a cation of Mg2+. And if we want to write that as an equation, we have Mg going into Mg2+ plus 2 electrons that are lost. So this is how to write, or this is how cations are formed. And this basic understanding of how sodium and magnesium form cations forms the basis for writing the cations of the remaining elements, I mean the first 20 elements. So if you find this lesson interesting, give it a thumbs up, like this video, and share it with other students you know benefit from lessons like this. For our next lesson, we'll be looking at how anions are formed after discussing how cations are formed. See you in that lesson.